Is that because it's is that from the product, or is it more Python based?
Yeah, I actually like the fact that the ML transformation from database and Python is the normal
Yep.
but then I still like the platform setup and storage setup,
Oh, okay. Yeah. Yeah, do you mind hearing? Yep. Yeah. Okay. Cool. All right, let's kick off. Hey everyone. Test. Hey everyone, we're gonna kick off in a minute. If you want to come and grab a seat and grab a slice on your way here as well, we'll get started just in a minute. All right. Hope everyone is doing fine in this amazing weather. Did anyone get caught in the rain? Drenched? No, just me? Okay. Awesome. Good to see everyone's faces here. We have two very amazing talks today. But before we get started, just want to thank our sponsors for today, so the Core Innovation Hub for the space, of course, and AWS is sponsoring the pizzas for tonight. So thank you to both of you for sponsoring. Tonight we have two very amazing talks. First speaker for tonight is Pallavi. Give you a bit of context. So Pallavi is a data engineer who is passionate about big data and analytics and has implemented data lake solutions for a diverse range of customers, especially in oil and gas, energy, transport, navigation sector. Okay, she'll be giving her first talk around data lake and fine-grained access control. We're going to hear that shortly. And the second talk is from none other than me. So I'll be talking about modern data platforms. So very exciting talks today. Hope you're looking forward to it. So without further ado, Pallavi, you ready to go?
Yep.
All right, here you go.
Thanks so much. A very good evening, everyone. My name is Pallavi Verma, and I work as a cloud architect with AWS Professional Services team. And Jonathan has given a bit of introduction about me already, so I skipped that part. But thank you so much, Jonathan, for giving me this opportunity to give a session here. So today I'll be talking about data lake and how we can use the data lake fine-grained access controls using one of the services, which is AWS Lake Formation. So in today's talk, I'll cover a bit of background around how data lake evolved, came into existence, and how we can put security and governance on top of it using lake formation. And then I'll dive deep into some of the permissions that we can add to provide those set of security guardrails and give a bit of demo. And I'll wrap it up with some of the best practices that you can use to work with lake formation. So let's get started. So what is a data lake? I'm sure you have come across this term quite a lot and you must be using that a lot in your organizations and company. But just to put it in simple terms, a data lake is something that you put as a centralized repository where you can dump all your data in, may it be structured or unstructured data. And many organizations are actually trying to pull all the data in from various silos and aggregate all that data into the data lake, which we now known into the data lake. And the main key benefits of using that are you can put all the data at one place. So you don't have to think about anything else. That's the single source of truth for the data. And you can take all the data that you want, transform it, and do whatever AI, ML capabilities or do analytics on top of it. Secondly, you can quickly ingest the data. So you don't have to think about any predefined schema. You can make the data lake in such a way that allows you to ingest all types of data. May it be real time, it could be structured, batch data, or you can just query it through a URL. So put that all data in, make your data lake capable enough to ingest it quickly, and lastly, it allows you to be flexible and scalable. And not just scalable around the storage, because we are storing in that data lake, but it gives you the capability to expand and separate the compute and the storage. So now we know about the data lake, we know what the benefits are. How can we build that on AWS? So there's a lot of ways.
Your slides aren't being updated on the live stream. Are you able to mirror this way so that we're getting?
It's already mirrored.
So what's coming through is just the presenter view,
Presented view.
not the slides that are on the screen.
Does this work?
I've still got the presenter view coming through. Could you maybe try sharing and sharing again?
Yeah.
Thank you.
Sorry for the pause.
Bring back the presentation.
It's there.
Sorry, folks, technical difficulties.
Yeah, that's fine.
Because it's sharing on this one.
Let's change this one.
We will. Okay, there we go. And selection.
Again. Okay, let's just use maybe.
You just want to maybe go back. Is that better?
Like, no, I've still got the same thing coming through.
Okay, we might have to stop and reshare. Okay. Is that any better?
Yes.
All right.
Thank you.
Is it still showing the? Sorry for that. So I was talking about the data lake architecture on AWS. There are a number of ways you can implement data lake in AWS. Of course, depending upon your the requirements of the customer, your use case. I'm just highlighting some of the services that are there in some of the analytic services that you can use to build your data lake. But most importantly, it starts from the central repository. So where you store your data, and for that, many customers have been using Amazon S3, which is simple storage service to dump all your data in because of number of reasons. It's highly available, durable, scalable. It's highly performant and cost effective. And most importantly, it integrates with all the other services, not even just AWS, but externally to third parties very smoothly and seamlessly. So let's jump onto security and governance. So now we have talked about what's the data lake, how we can build it in AWS. How can you build the security and governance on top of it? So up till now, what's happening is we are sharing the data, and all the organizations are taking the decisions based on the data we have and validate through data. And we are using the data to empower ourselves and our decisions. But what we need to think more of is the data is scaling at a rapid pace, but as well as the organizations who are using those data to make the data-driven decisions, they are scaling as well. And for that, we need to think of a different approach, like thinking of data as a product. So what it enables is you can share your data across different organizations and make sure that your data is discoverable, addressable, and secure. And to do that, we have Lake Formation as AWS service that controls all your security and governance on top of that data. So it gives you the confidence to share your data by making sure that you are only giving the authorized access, you have the right permissions and all the compliance requirements, etc. And it enables the end customers to make sure that you break down all the data silos and put the data into confidence. So how does the lake formation fit in the whole data lake like pipeline or data lake cycle? First, we can ingest the data from various different sources. As I mentioned, it could be real-time, batch data, non-structured data. Put that into S3, and once it's loaded in S3, we can use Glue Catalog. That's a data catalog service provided by AWS that enables you to see all the data in lake formation and then add the permissions on top of it. So those permissions will enable the data sharing with different accounts or different organizations and making sure that your data is secure and governed. Now I'll deep dive into lake formation permissions. So now we know what lake formation is used for. The permissions, it consists of three main things. So you can think as a fundamentals like it's a combination of three things: principal, permissions, and resources. What is a principal? It's a IAM user. It could be a role. It could be a service, any SAML group from groups or user that you want to pull it from outside or any external account. So you can give permissions to all different sort of principles that is mentioned in the lake formation console, and I'll show you that in a minute. Then use the permissions and resources. What are the resources? So these are the catalog, databases, tables. These are the some of the things that you can add as resources in your permission. And then the database permissions are of two types, like the metadata and the data. So it's very similar to what we use in SQL databases, like granting the table access, giving the select, insert, or delete access to the user. So once we have these three things, there's two ways we can assign the permission, and I'll show you in the demo these two different ways. So first is the named resource method. This means that you are explicitly mentioning what database you are giving the permission to, what table are you giving the permission. And LF tag is lake formation tag. What this does is it assigns a tag to a particular table. It could be at a column level, it could be at a database level, and then use that tag to give permissions. And if we are adding both of these to a particular resource, let's say table A has both kind of methods already added as permissions, then it would be a union of these two permissions. So going a bit deeper, now let's think of a scenario. I have a role which is Sales Manager US. What I want this role is I'm admin and I want to give the permissions to this role so that it can access the customer's data only for a specific country. Since he's located in US, so I just want to make sure he is accessing the data only from United States customer. So what I need to do here is I need to create a data cell filter where I'll put the condition, the filter expression, which is United countries equal to United States, just like a where clause in SQL query, and then assign it a name. So that's a data filter. And next I'll create a permission set. So the permission, as I told before, it consists of principal, which would be my role here. Next, I would see what resource I want to add, which is this data filter I created above. And next, I'll give the permissions, which is the select permission. So that's how you can easily give the permissions for a row. And you can also put some of the columns here, like which columns you want to exclude or include. And what this will do is combine the row and column to give it a cell level access. So you can you can get those fine grained controls even at the cell level. So how minute is the permission set here, which we can give through this data filters. So let me show you in the demo. Just as I mentioned before, you need to create a data lake before and have a glue catalog. So I've already pre-populated that for this demo. So these are the databases I'm using. So for example, a stage customer. Yeah. So let's say we have a stage database, and inside that we have a couple of tables, stage customer, stage sales. And then to add the permission, so my first use case is to show adding it by named resource method. This is a lake formation UI console. On the left hand side, we first need to go to the data lake permissions and then click on grant. And there would be things populated here. For example, you need to enter your principal, which would be sales manager US. Manager US, and then you will select this named resource method. Here you can select the database. I'm selecting the stage customers data table to put the country as United States. And then you need to select the filter. So I'll just create the filter as regional sales US. The database and table is already populated. You can select the columns. I'm just using all as of now. And then putting the query as country is equal to United States. Sorry, just using one hand, and then create filter. Once you have created the filter, you need to select this, and it will give you the permission sets, which is the third thing we need to do. Give select permissions and click grant. So that's what you all need to do to give a permission to a particular user role. And I have already logged in as the sales manager US here, and run the query as distinct country in the stage customers to find out what are the countries that for which we can see the data. And you can see here it's only United States. And if I go back to my admin role, I can see the 3 countries for which I can see the whole data. So in this way, we have added the row filters and granted access just to the sales manager US role to see only those rows. So that's the first use case. Second is you can also do the column filters, which I highlighted in the demo. And next is using the LF tags method. So what this method says, you have to first define the tag. So if you have used AWS console before, it's like you can attach tag to any of the services. But here it's a little bit different. What you need to do first is create a tag catalog, LF tags catalog, where you will define like this is my tag. I want to classify my data as sensitive or classified, or in other words, public. So what I can do here is I have a database. I have attached the tag classification as sensitive. So this will make sure as soon as I attach the tag at database level, it inherits all the permissions to the table and at column level. So now my table, all of the tables inside this database will have sensitive tag and also all the columns. So that's the first thing. Second, we can do override of the tag. how this works is we can assign, we can remove the sensitive tag value and assign the classified tag. So this will be overridden, and now this whole table, including the columns, will inherit this new tag value. And then we can do another level of overriding, which is at a column level. So once the let's say here I am doing only for column C, I am moving it back to sensitive, and then it will change, and this column would be classified as sensitive. But how do you assign those permissions? So let me go through another use case where I'll go back again to my Lake Formation console, and for the LF tags, I have already created that tag, that master ontology list that I mentioned. And next, go to the database. Let's say I'm choosing stage. I'll edit the LF tags and assign classification as classified and hit save. So now all the database tables columns that are classified can have access to those like that particular catalog resources. Next, I need to add the lake formation permission. I'll go again to the data lake permissions, quite similar to what I did earlier, but this time I'll do it for a global sales manager for whom I can see all the records for other countries, but I just want to remove all the sensitive columns from that. So this is the principal. Next, I'll move to the LF tag, and I attach the tag as classification and just the classified value here, and give describe and select permissions. So this is how you can give the permissions for LF tags. Just one more step to do, the overriding which I was showing. So I can remove some of the columns for which I don't want to explicitly mention or assign it to a particular role. So for example, for the global sales manager, I'll go to the database. Let's say I go to a table, stage customers, and inside that I'll edit the schema and choose particular columns. For example, email, address, and birthday. These are some of the sensitive columns for which I don't want to give the access. I'll click select the tags, and for this I'll choose the sensitive value instead of classified and hit save. So I've already did it. Just want to show you how we can override the value for the columns or even tables. Once this is done, we can just go to the user role, which is the sales manager, global sales manager. And once you hit this query, you can see we can only see the 5 columns, and it is excluding all the PI columns which we removed. And if I just hit refresh, you can see here stage customers, and these are the only columns we are seeing. So that's the second use case where I'm using the LF tag method to just do a column filter. In summary, what I did was for the global sales manager, I put the select permission, and this is the tag I used. And I did do a bit of tag configuration before for doing attachment to database, doing a bit of overriding. And then as a result, I can see, like for the second table, I didn't do anything, so I would be able to see all the columns. But for the sales customer database, I would only see the columns with the classified tag. So things to remember: the lake formation consists of like 3 things while assigning the permissions. First is the principal, the permissions, and the sources. And then there are 2 ways which you can pick and choose which you want based on your use case. And then you can assign it to a column at a row level or even at a cell level. So what are the best practices? As I told you, LF tags, you can assign it when you have like thousands of database and tables, and it will help you to scale quite easily. So some of the best practices here are try to use the tag-based access control, which is the tag instead of the other method, which will help you to scale dynamically. Then just there's a clause here, we don't have the row or cell level filter supporting the ls tags as of now. But you can learn more about what I showed. There's a workshop, you have a cloud formation template you can spin, and all of your data lake resources will be there to you to try out the lake formation settings and permissions. So would highly recommend you all to go and check this out. That's all for today. I hope you enjoy it, and I'll open the floor for any question and answers.
Okay, I think I'm fine. It's okay. Last time I used Lake Formation, it didn't have much support for CloudFormation, especially like around the data location that you had to set up. You had to manually click offset. Is that fixed? Is it better now?
When did you check that? Is that
1.5 years ago.
okay? I haven't looked at that part, to be honest, but yeah, I can check and get back to you.
I remember like you think most
Just
of
for the
things-
data location part, right? Because
it was like more than data location. A few things that wasn't supported by CloudFormation.
okay, do you mind if you send me this and I can check it and get back to you? Yeah, thanks. Any other questions?
Yeah, just the LF tags. Can you speak about any limits on those? So how many tags you can have, or how many categories of tag?
Yeah, so on the top of my mind, you can have like there's a tag value key and tag value. So the question is basically what's the limit on LF tag, right? So to add one LF tag, which is the key, you can add 15 values at the moment. But you can obviously you can increase it by raising a support ticket. And for the LF tags, I'm assuming it's close to 100, but I'm not very sure. So I can get back to you on that. But it's like a soft limit, so you can always increase if it scales. But I think most of the users who use Lake Formation, they won't have that many like tags. They'll have more values to it, so that they can distinguish between the data basically. Does that make sense?
Yeah, so could you tag a resource with multiple values? So say you've got a tag for users and you want to give multiple groups access to something. Can you do that, or is it stuff?
You mean multiple catalog resources?
Yeah, so I guess the example you had was the category of the data was classified as sensitive.
Yeah.
If I was to look at perhaps it's username or something, would I be able to say A and B? This is both A and B. This tag. So I'm tagging a table, and its classification is.
Okay, yeah, I got your question. I think you are looking after if you can add more than one tag to a particular resource.
Yeah, or more than one value for it.
Okay, so for value, you can't. You just have to assign one value for if you're using one tag. But for a same table, you can add more tags. Let's say I just created one classification. Let's say you create another one as data roles, and there's like data analyst, data engineer, and then you can assign that tag as well.
You mentioned that you need a database before you can assign the roles. Does that mean you assign the security to the bucket and folder levels separately?
Can you repeat?
So you mentioned you need a database before you can create the roles and tags.
You don't need a database, but you need a data catalog. So once your data is in S3, you crawl and create a data catalog. So it's data catalog here we are using is Glue, and it's automatically like created in forms of databases and tables that I showed you. It's not the real database, but it's only the metadata of the data. Does that make sense?
So if I was
Yeah,
the same
it's-
user, I can go down into the bucket folder and look at these files. Same security model will apply.
Okay, so if you are logged in with a user, let's say sales manager, and you have only the access for the particular rows, and you go into the S2 bucket, yes, you won't be able to access the other data. That's the, but I can come back to you with more information if you want.
I think like they don't need the data access, as long as they've got the catalog access, they can query the data through Athena without actually giving them permission on S3 button.
Yeah, that's right. It's coming from Athena, like it's picking the information sets from Athena and Blue catalog. And Lake Formation is just sitting on the top, controlling the governance side of things.
How compatible is the data lake formation with third-party BI tools?
It's compatible. So as I said, you are actually using Athena to query, and Athena is compatible with any third-party tools like Tableau and even Redshift. If you put your data in Redshift, you can connect it through that, and it will use the same level of permissions.
Awesome. Thanks, Pallavi.
Thank you so much.
Thank you, Pallavi. That was awesome. Really great to hear about amazing stuff you can do with data these days. We didn't used to be able to do governance on data lakes, so that's really cool to see. Thanks for that.
Should I stop sharing?
All right, let me know, Tom, when. Is that good? Cool. Awesome. Feel free to grab a drink of water. We're just going to do a quick 1-minute interval. I'm just going to do a quick announcement for Data Eng Bites. So Data Engineering Meetup, our kind of big parent or kind of overarching theme is to host a conference as well. So we're hosting yet another conference this year. It's going to be hosted in Melbourne and Sydney on the 27th and 29th of September. So if you're in town, happen to be in Melbourne or Sydney during the time, feel free to get a ticket and head down there. If you're looking to be a speaker as well, you want to share insights over in one of the cities, we're looking for speakers as well. So I'm just going to click over here. Call for speaker ends on the 6th of, it opens on the 6th of June, and 10th of July is the last day you can submit your present talks. So feel free to drop something in if you're interested. Link there is sessionize.com/dataengbites-2022. Awesome. All right, let's flick on over back to topic for today. All right, so welcome to my talk. I'm really excited today to share with you about key design principles that I used when building modern data platforms for a company called Blike. I'll talk about what Blike is in a second. A little bit about me, for those of you who have not met me and not introduced. So today I'm working as an analytics engineer at Canva. Working at a few other startups as well on the side. One of them is Blike, which is what we're hearing about today. And just launched my data engineering bootcamp as well today, actually. So I'm going to be talking just a minute about what that is, because a bit of a blurb there. And in the past, you might have seen me at some of those other companies through consulting roles. Over the years, yeah, we've 10 platforms, trained over 100 people in data. All right, so just a little bit about data engineering camp, I promise, and we'll get on to the actual topic today. So the issue with, I guess, data engineering today is that there aren't enough data engineers on the market. So does anyone want to take a guess for every one software engineer there is in the market? For every one software engineer job posting there are on the market, how many software engineers do you think there are to fill that role? Anyone want to take a quick guess?
Right now? Or
Yeah, right now, yeah. This was done, I think, a few days ago. I just did some LinkedIn searches and got a list of numbers of people.
0.5.
0.5. So there's not enough people, software engineers, The answer is 15. It's actually quite a lot. A lot of people with software engineer as a title, but not a lot of software engineering job postings at the moment. Data analyst is 5 to 1. Anyone want to guess what the number is for data scientists?
We're back in the low decimal.
Decimals, not quite. It's actually 2. It's not too bad. And of course, the reason why I'm launching this bootcamp is because the data engineer is 1. So what that means really is that to fill the demand for jobs, everyone will need to quit their jobs today in order to join those jobs that are being posted, which is not very feasible. So yeah, that's why I'm launching this bootcamp, is to bridge the gap between supply and demand. So if you're a professional looking to become a data engineer, this is a really great way to pick up skills and get into the field. If you're a company, this is a great way to train up your staff. Maybe you have data analysts or software engineers in your business and you kind of want to transition them into data eng. Yeah, this is great for you guys as well. So details are here, 14 weeks part-time, all done through Zoom, so you don't have to worry about COVID, you can do it through your own homes. That's a stack that we'll learn. It's pretty much a stack I use for work at Canva, at various other places I've been at. And we kick off on the 5th of September, and we'll be offering a 25% early bird if you sign up before the 1st of July. For more details, you can head on to that link. All right, that was my blurb done. So today we're going to chat quickly about who is Blike, take you through a quick tour of our data platform, and then we'll talk about the interesting bits, which are key design principles we use when designing this data platform. So who is Blike? How many of you here have heard of novated leases for cars? Or maybe you are on a novated lease for a car? Yep, a couple of hands gone up. If you have not heard of what novated leases are, we'll explain, but for those of you who know, we're essentially that, but for bicycles. For those who don't know what that is, essentially you buy a bicycle using pre-tax salary sacrifice, and that's fully endorsed by the UK government. So the UK government is trying to reduce carbon emissions, and so they want to encourage more people to travel to work using bicycles instead. And so they said, you know what, buy a bike through your salary sacrifice, we'll not charge you tax on that. So usually you'd save somewhere between 25 to 40% on the purchase of a bicycle through this method. All right, so what we do is we sell you a bike. You have a plan of, say, 24 months. You pay £83 a month. And at the end, you can have a lump sum payment to own the bike fully outright. Okay, so that's the scheme. It's also based in the UK, by the way. In terms of actually technicalities and how it all works, there's a kind of a few players in this story. We've got this in the middle here is Blike. We've got debt investors over there who want to invest their cash that they've got and receive some kind of interest on that cash. We've got bike manufacturers who want to sell bikes to people, and we've got consumers. And these consumers, they may not have all the cash up front today to be able to buy a bicycle fully outright because it can be pretty pricey, especially if getting e-bikes these days. Or perhaps you might want to pay in installments, and you want to actually benefit from that scheme that the government's providing, so you save somewhere between 20 to 45% on the cost. So how it works is the investors give us some money, invest in our business. We take that money and we wait till we get an order from a consumer. The consumer comes to us and say, hey, we actually want to buy a bicycle through the scheme. Then we receive the order, we send that order through to the bike manufacturers, we give them some cash, they go and ship the bike and send it to our customers. Customers receive the bike and they're happy and they provide a payment using salary sacrifice to us. And then we divvy up that payment between ourselves and the debt investors. So that's how we pay back our investors. And over time, if this cycle keeps repeating itself, we make some money, mainly because of the UK government offering that discount on the bikes. Any questions on that scheme? So I guess the point from that slide really is to kind of show you that we do have a few moving parts. There's the debt investors that need to know, are the loans delinquent? What's the, the risk ratio, risk factor for the consumers? We also package some of the loans up into tranches and give it different ratings for different types of risks that the debt investors are interested in. We also need to know what bikes are actually very popular on our site, so we can readjust our kind of recommendations for the bikes that get shown first and second and third. And consumers as well kind of just want to know what the risk ratings are in general. Cool. So CFO said to me, "Hey John, we need to know our financial and risk performance for ourselves and also for our debt investors. So could you solve that for me?" And so what I helped him to do was to build a data platform that solved that issue. This is what our data platform looks like. I'll take you through it step by step, going from the left to the right. And as we go, if you have questions as well, just feel free to stop and ask. Starting way here on the left, I'm using a service called Fivetran. It's a SaaS service, software as a service. Fivetran is really great at performing data integration. And because all our services are on the cloud, we don't really have to worry about anything that's on-prem. So it's really, really awesome. So Fivetran does the data integration for us for all these data sources here on the left. You will see as well, I've got a lot of AWS lambdas sitting there, and that's because some of the connectors are not provided out of the box with Fivetran, but they provide lambdas that allows you to create your own custom connectors. Moving on, so Fivetran takes all the data from the left-hand side, drops it into a database. I've chosen to go with Postgres for this use case because we don't have huge amounts of volumes of data at the moment. And I don't expect us to really hit like terabyte or even petabyte scale ever. So Postgres is a really cheap option hosted on RDS. Very, very cheap, very, very happy. We ingest something like 100 tables. Then we create some data transformations. We have about 50 of those. We transform our data using a tool called dbt. If you haven't heard of it, don't worry. We'll go a little bit into it shortly. But essentially, we create transformations to do some cleaning, some dimensional modeling. If you heard of Kimball, that's the methodology we use in this case. And we get the data into a shape that is nice. That's the 50 tables that's produced from those models. And finally, we can now serve that data out to users. So we have two means of consumptions. One is the API. So that's the API that we built using Fast API. It's a Python library. And we hosted it on AWS Lambda. It's really, really good. It's very, very cheap. And the other way of consumption as well is we create Power BI dashboards. So our Blike management, the CFO and CEO are interested to know how we're performing as a business. And the investors as well, providing the capital to us, is also interested to know. So we've created a dashboard using Power BI here. And you notice that this drop down here on the right-hand side, that's actually a way to drop down and look at what the business was or the performance of the portfolio was at a particular point in time. So I've modeled the data in such a way that you can time travel and you can look at a specific day and look at what the performance was of the portfolio. Cool. We've got little bits of supporting services as well. One of them is GitHub Actions. So CI/CD is something that we do quite a lot of. It's just really great to be able to write and then have the code very easily deployed after you merge your TR into the main branch. Show of hands, who knows what CI/CD is? Okay, so we're all pretty familiar. If you're not, if we get time, we can talk about it. If you have questions, I can answer as well. And we use Terraform to do all of the infrastructure as code for this service. Okay? So this is just me doing a print statement to show that we've got a whole bunch of different environments here. We've got two environments actually, non-prod and prod. And then all these are the Terraform state files, which essentially keeps track of the infrastructure for us. So those are all the infrastructure that we deploy into AWS and also to Fivetran. Okay, that was a bit of a mouthful. So any questions on the overarching data platform?
We want to step back from one line, which was about how the UK government comes into the way the business model works.
Sure. Right, so the UK government is offering a scheme known as Cycle to Work. And that scheme allows people to buy a bike through a salary sacrifice. And that allows them to therefore save on 20 to 45% tax because they're not paying tax. If they were to say buy a bike using the cash they've got, that would be after tax. So they would have paid that. So this allows them to save that. Hopefully that makes sense. Cool. All right, so design principles when we design this platform. So there are 5 key principles we used when we designed this data platform. The first one is loose coupling. Second is automate data integration. Third is declarative programming. Fourth is infrastructure as code, and number 5 is use serverless or SaaS where we can. So we'll take you through the first one, and we'll go through each. So loose coupling. So what does loose coupling actually mean? To understand what that means, we first have to understand what tight coupling is. Tight coupling is pretty much the standard way of doing things that we're very used to. So for example, you want to write a data pipeline to do extract, load, or transform, or even extract, transform, load, whichever you prefer. What typically happens, you tend to write the code in the same tool that you're orchestrating the whole thing. So the E and L and the T, they're all part of the same code base. For example, you might write something in Python, you're going to do it end-to-end using a single Python script. Or you might use something like Data Factory, for example, AWS Glue, and you kind of do everything in one go. Now, what loose coupling is to say, hey, let's actually break the E and L and the T. So E and L is one step, and then the transformations is another separate step. And what that means, what that allows us to do is to use the best-in-class tools for each of those steps. For example, the E and L side, there are a whole bunch of different services today that are built and designed to perform the E and L part extremely well. So tools like Fivetran, which we use. AirBytes is a really popular one these days as well. It's open source. DMS from AWS, of course. So that really is very easy to use because you just point the service to your source data and provide the credentials to your target database, and it copies the data across for you without you having to worry about column names, data types, etc. Then once the data lands into your database, you use the appropriate transformation tool of your choice. Spark is a very popular one as well, SQL, and of course dbt, which is what we use. Now, some things to watch out when you do decide to have loose coupling is scheduling hell. So what I mean by that, so E&L, right? We started it at day 0. We noticed that it starts at 8 a.m. And then it ends. It takes 1 hour to run. It ends at 9 a.m. Okay. So we decide then, therefore, we should trigger our transformations around 9:30. Give it 30 minutes of window in case it exceeds. All right. Everything runs fine. Day 1, day 2 runs fine until you get to day 3. Suddenly, you have more volumes of data, and now the ingestion is actually taking longer than expected, and now you're transforming on yesterday's data. So it doesn't quite work. So how do we resolve this in our platform? So what we use is what we call dependency triggers. That's a feature that comes out of Fivetran. If you don't have that out of your toolbox, that's okay. You can kind of build it yourself using lambdas and so forth. But very nice that we have it out of the box with Fivetran. What this allows us to do is to say, once the data has been ingested, go ahead and run the appropriate transformations for this model. So you can see here, we're just saying specify the model, and the model in its code has references in dbt. It will actually figure out the lineage and say, okay, run this thing when the source has been, or the upstream thing has been ingested. So that's really, really neat. Any questions on loose coupling?
Are you doing full ingestions every time?
Yes, we are. Yes. So the question was, are we doing full ingestions every time? And the answer is yes. So there are a couple of ways you can avoid that. So currently we're just running a select star against source to pull out all the data out. And then, but when we do the merge into our target database, Fivetran actually keeps track of the cursor. So it knows which record has been ingested up to. And so it only ingests anything after that previous cursor. But if you want to actually do everything without doing select star, then the approach to do it these days is to use CDC, so change data capture. So you can enable that on databases that do support that. And what happens is every event that occurs on that database will be kept in a transaction log, and then you can read from that log, and the cursor will now keep track of where you last left off. So that's a better way to do things. Hope it's small, so we don't mind select stars. Yes?
Sorry, do you know how to get DBT to keep a checkpoint?
DBT to keep a checkpoint. Yes, so DBT supports a feature called incremental loads.
It doesn't actually work.
Doesn't work? All right, I need to give that a crack. I don't know, it should work. I don't know.
It's
Yeah.
very interesting. It's just the flag. It's called incremental load because
Yes.
you expect it to keep a checkpoint. It doesn't. You have
Yes.
to put an if condition yourself of like, if that checkpoint is true, then you have your business logic around your select statement, which is so weird.
Okay, I'll give it a crack and I'll let you know. Yeah, that's an interesting one. Would have thought it would work out of the box.
There's a question here from online. Do you have CI/CD in terms of changes in pipeline? If so, could you share to us the process of deployment?
Yeah, sure. So that's something I have a slide with that. I will instead jump up to our GitHub, and then we'll flip back the slide. So, so I use GitHub Actions for CI/CD. On the bit hard to see, sorry. Just going to zoom in here. So the way we structured our CI/CD, by the way, those of you not familiar with CI/CD, CI/CD is just a way to automatically deploy code into your target environment. So non-prod environment or prod environment, CI/CD handles that for us. We've broken up our CI/CD pipelines into two parts. One is what we call the reuse pipelines, or the child pipelines. These are things that we're going to reuse for every target environment. So non-prod, prod, if you have like different conventions like dev, test, prod, then this is going to be called 3 times. And this will be called through the parent pipelines, which are any one of these deploy ones here. If I just go into one of them, the deploy API, you'll see I can just trigger that off, and I can select my target environment, non-prod, prod. Okay. So to answer the question, how do we use CI/CD? Currently, it's a manual trigger. I'm much more used to, of course, using like PR triggers or merge triggers and things like that, which means that once the code's been reviewed, then we deploy. But I'm using the free version of GitHub Actions, so I have to manually press the button. Okay. Cool. Let's back to the slides. All right, so the next piece of the puzzle, the next key principle is to automate data integration. So how many of you here have written some data integration pipelines in your lifetime? Okay. How many of you here enjoy writing? Keep your hands up if you enjoy writing pipelines. Oh, any? Okay. All right. It's special. Yeah, I think most of us would agree it's not an enjoyable process, especially when you have, and this is not, a fake number or anything. This is actually genuine. There's tens of thousands of possible source systems that you might need to pull data from. Your business might use CockroachDB, Salesforce, Google Analytics, Postgres. So there's a whole bunch of different combinations that you might need to ingest data from, especially if you're in consulting. So if you're in consulting, you work with different customers, it's always a nightmare to kind of reorient and rewrite the same thing over and over again. So data integration tool really makes that really easy for us. Supports connectors to sources, and then supports connectors to land the data into your destinations. So you can have possibly hundreds of different target databases, Snowflake, BigQuery, Databricks, etc. So those things will, the data integration tool will actually figure out the mapping that needs to happen to copy data across. So where possible, try to use it, okay? Because if you don't, this is what it looks like, right? Many steps. For example, you need to write the extraction logic. How do you get the data out from the source system? It could be a REST API, it could be a SQL database. Then you need to create a target schema for when your data gets to the destination. You need to then think about how do you map the column names from source to target. Sometimes those may differ. You need to think about data type mappings. How do you map source to target data types? Once you figure all that out, then now you can finally push your data across. How do you push your data across? How do you push it in the most efficient way possible? Well, you need to create a cursor. All right, you do that. Then now, all right, great. We create connection strings for source and target. We set a sync schedule. And now we have to repeat that for thousands of different tables, which is very tiring. So don't do that. Instead, use a data integration tool. All you need to really do, this is oversimplifying things, of course, but if you just specify source in a target connection string, it reads the whole source schema, maps everything in the source database across your target database. Done. Okay. So what we did at Blike, we used Fivetran. In Fivetran, we have 2 environments, non-prod and prod. For our non-prod environment, we do syncs on an ad hoc basis. For prod, we have a scheduled sync of that runs every hour. I did mention to you before, we use AWS Lambdas for any connectors that are not supported in Fivetran. So you see a bunch of them there. Each connector has many tables within that. So think of a connector as a source system. So within a database or source system, we have tens of database tables. In terms of what the lambdas look like, this is pretty much it. It's fairly simple code. This is in Python. Create a connection to our database. create connection and extract data from our source, then check what data has been deleted at source. This is because we have hard deletes. Then we need to send the data back to Fivetran in this kind of shape. So as long as you can get the data back in this shape, Fivetran can then process that and keep the cursors going. All right, one thing I would say though with using a SaaS data integration tool is that if your data volumes are small, like ours at Blike, then a data integration tool makes a lot of sense because, yeah, here we are. So the dollars per row is pretty cheap. Data volumes aren't very large, but as soon as you get to very high volumes, you might want to think about hosting your own infrastructure. Okay, so hosting your own infrastructure, it gets cheaper as it goes. But if you can imagine you have a cluster or a web server running 24/7, it can cost you a lot if you're just processing one record per day or something. Cool, that's that principle. Any questions on that one? Yes, Anik?
I was just curious, I haven't used Fivetran before myself.
Yep.
And if you compare it to sort of the manual data integration part, do you specify like a target schema with Fivetran? So like if it does the automatic mapping, sort of how do you ensure that if your source changes types or like fields, like that it still matches the target that you want?
Yeah, that's a good question. So I don't actually know the answers to that specific one. So Fivetran has a lot of built-in logic to perform those things. When the question was, what happens if source schema changes? How does it replicate into the target? Fivetran has its own like rule sets that it uses to do the replication across. I don't know specifically what will happen in that scenario, but the docs would spell it out word for word what exactly would happen. Yeah. Yes.
Do you also make the connector creation as well?
Do I do the connector creation?
Do you automate it through the Fivetran APIs or not?
Yes, as I said, a sync schedule, so I can say run every hour. Is that your question, or?
No, for creating connections, like say a big company, they've got like so many different sources and stuff. Do you automate the creation of the connectors as well?
No, because we need the connection strings to know what we need someone from the business to say, hey, we've got this system running. Then we will go back to them and say, give us connection strings to connect that. Then we put that connection string to Fivetran. Then that's pretty much all the setup done for Fivetran. Yeah. Cool. All right. So the next principle, and one of my favorites actually, is declarative programming. So for those of you who've heard of this thing before, imperative versus declarative. That's an age-old argument that kind of began like in the 1980s or something, maybe even earlier before that. But what it means is that imperative programming typically looks something like that. Okay, so imperative programming is you specifying how the program should do something, and you have to explicitly tell it how it should do it. And so to do something simple like multiplying all the values in my list by 2, you have to write a function that does this. So you have to write a function that looks through each element in a list and then multiplies each element by 2 and then return the entire result back to the function that's calling it. So this is something you would write using the declarative paradigm. However, if you look at the imperative paradigm, if you look at the declarative side, you just specify what you want to see, and you don't worry about the implementation details, right? The software or the engine or the program is supposed to figure that out for you. So SQL, for example, is a declarative programming language, and so we just say select n times 2. We let SQL engine decide how it goes and implements that. It might use a for loop, it might use something else, a while loop, I don't know, right? So SQL worries about that. So that's a really neat way of coding, and the reason being that it tends to be much quicker to get to the outcome, right? I don't have to write long for loops and think about things on a very low level. The other thing as well is that it enables now the data analysts within our business to actually write code and create data models and do transformations. In the past, if we kept everything in Python and Scala and write very low-level code, then we might fall into that issue where we're bottlenecked, right? Only certain people within the business can do data transformations. I won't say that Spark, however, Spark falls in the declarative side. So if you're using Spark, that's actually pretty good. Lastly, as well, although it's custom logic, some of the custom logic is not very easily done in declarative. If you try to do stock procs that calls stock procs or something like that, so there might be workarounds. Like DBT has come up with this thing called macros, which helps. But sometimes you do have to fall back on creating something if you're in a very kind of weird use case. The other thing that people don't normally think about when it comes to this comparison between imperative and declarative is data pipelines. So what I mean by data pipelines, so we often create transformations, and we create different transformations. Like transformation C should run before B, before A, for example, right? You have a flow of which the data needs to be transformed. And so we create data pipelines to handle that, and typically this is what a data pipeline will look like. This is something written in Airflow. So this here is you chaining up the steps. So you're saying here, run this T0 first before we run T1, before we run T2 and T3, before we run the next and the next, and so forth. That can be pretty complex to try and manage, especially when you've got lots and lots of kind of interwoven transformation logic that runs in very weird orders. On the flip side, if we do something using say DBT, for example, over there, all you need to do is just to write a ref function to say, this transformation that I'm creating here depends on this other table. And if you write enough of that, DBT will actually create a DAG, directed acyclic graph, and it knows which order it should perform transformations in. So that's declarative. You don't have to think about specifying the order yourself. And that's really beautiful, I think, because I'm not sure if I have a slide here. It allows us to actually create DAGs like that without having to worry about the interdependencies. So you can see here, my dates table, for example, I use it quite often in a whole bunch of places. And you can see it's kind of like interwoven. Think about trying to write this out by hand. It's actually quite complex. Cool. So what do we actually do at Blike? At Blike, we have three levels of data transformations. So source tables is what Fivetran lands into our Postgres database. We then pick that data up and we create staging tables. What we do here is we deduplicate the data, or if we have, say, JSON in the data, we flatten that out. Then we also run some tests here using DBT's generic YAML data tests. So it does basic things like checking for uniqueness and not null. Then we proceed on to create our serving tables, which are model tables using Kimbo dimensional modeling. And there we actually create some custom tests as well. I'll show you what that looks like in a second. Here is the DBT code. You can see here, to get to the staging tables, we actually use this function called source. So we're referring to a source table, and that's how it really creates that DAG I was telling you about earlier. Then on the next slide there, serving, we use a different one called ref, and that refers to an existing model that's created, and that's how it creates the declarative DAGs as well. And testing-wise, so this is YAML. This is the generic test that comes out of the box. Very easy. Just write a few lines there. It runs a test for us as well. If you do need to write custom tests, this is what a custom test session looks like using DBT. So this here is just checking if my amount is null or amount is 0, because it shouldn't be. We shouldn't have any values, loans that have a value of 0. That's the DAG. All right, that was it. Any questions on declarative programming? All right, 2 more. How are we going? Good? All right, 2 more to go. Infrastructure as code. Everyone here heard of infrastructure? Who hasn't heard of infrastructure as code? Shy? Okay, cool. So everyone probably has heard of it, or if you haven't, it's basically deploying your infrastructure, which is your cloud services, using code. So rather than doing it by hand, which is ClickOps, clicking and deploying AWS services or Fivetran services, you're using code to specify the configuration. What that gives us is consistency. We can create an environment exactly the way we want it every single time. It's automated, so we want to say deploy, test, and prod. We can do so in a very automated fashion. But it is actually harder to get started. If you're just a beginner, you're learning cloud, I would just suggest doing it by hand. It's okay. But when you're starting to get into more enterprise and more like doing things with scale, then you need to start thinking about maybe it's worth investing into learning infrastructure as code. Okay. All right, so there are a whole bunch of different infrastructure as code languages we could use. AWS has its own thing called AWS CLI. I think what's it called again? The formation stuff or cloud formation, that's it. Azure has its own thing. It has ARM templates and bicep templates and so forth. But rather than trying to learn each of the cloud providers' preferred language, we can use a kind of someone that's kind of very neutral, like Switzerland of infrastructure as code called Terraform. And what that allows us to do is using a single language, we can now deploy to a whole bunch of different, what they call providers, cloud services. So we can write the same language, and it doesn't take much to change and jig it a little bit. And we can now deploy to AWS, GCP, Azure, and 100+ different other providers as well. So for us, our providers are AWS and Fivetran. So we just use Terraform to deploy to those two. And here's what the Terraform code looks like. So it's actually just like kind of looks like a YAML. It's a config file. You just pass it some variables. Over here, you can see we're creating a resource. So we're saying create for us an AWS Lambda function with the name called Python Lambda. And similarly, create for us a resource called Fivetran Connector with the name of Airtable Lambda OKR tracking, whatever. And then within that, we're just configuration that we specify. So for example, how often we want the sync to run, 30 minutes, 1 hour, whatever. We can configure all that through code. Okay, that was infrastructure as code. Any questions there? Cool. Last one. So last one here is a bit of a debate at the moment. So there are kind of two ways we can set up our infrastructure or host our infrastructure. We could have gone with something like IaaS or PaaS. So these are just slangs, if you will, to say host infrastructures yourselves. Or we can use something like a software as a service or serverless, meaning we let the cloud provider or the software provider worry about the infrastructure for us. Because we're really small and we don't have huge data volumes, that's okay. We're going to go with the serverless option. We only pay for what we use per execution, usually, or per record ingested in the case of Fivetran. And we can deploy and forget. We let the cloud platform take care of the rest. For example, AWS Lambda is a good example of that. Just deploy your code, AWS figures everything else out. But you do get less control over what you can do with the service, and it gets very expensive if you're doing very large volumes of data. Okay, so I think I have a slide here. So just bringing this slide back quickly. What I mean by that is exactly this diagram here. So if you're processing small amounts of data, go ahead, use serverless, Fivetran, SaaS, whatever. That's really, really cheap and makes sense. But if you start to process very large volumes of data, like we do at Canva, for example, we get something like 100,000 events per second, which is 8.6 billion records per day. If you're doing something like that, and you're doing Fivetran pricing model, you're going to be paying $8.6 billion a day or something like that. Something ridiculous, right? So definitely choose the right architecture for your data volumes. So what we do is, Fivetran and Lambdas for data ingestion. And because our APIs are not requested by our debt investors every single day, we hosted on AWS Lambda. That's really cheap. You need to pay microcents for every execution. I think in fact it's free for up to 10,000 requests or something. Okay, so that's our AWS bill. That's both prod and non-prod. $60 US a month. That's pretty good. That's thanks to the serverless things that we're doing here. And Fivetran as well, we need paying per record ingested. We ingest something like 12,000 records, but we do some transformation, so that kind of makes it a bit bigger. But that's both for non-prod and prod. All right, so if you're interested to, learn more into the first principles and the ideas behind the talk I just gave, there's a really good book by Martin Kleppman called Designing Data-Intensive Applications. He goes into, how do you design reliable, as it says here, reliable, scalable, maintainable systems, and the thinking behind making those decisions. Lastly, before we open up the floor for questions, just a call out again. If you like what I'm saying here today, there's more of that in my bootcamp. We're going to go through everything and teach you the stack from end to end. All right, so questions? Yes?
Just curious, when you are designing a solution or think about a solution, have you ever have to consider Azure as well, as opposed to AWS that you buy?
Yeah, so Azure versus AWS, I guess is the question. When do you use which? I've done probably 8 data platforms in Azure, so I know Azure pretty well. Azure is very popular here in Perth because Microsoft has relationships with folks, and you're using Office 365, so why not use Azure? So both of them are I don't know, similar. I would say AWS was the first, of course, to go into the cloud. They probably have the most range of services as well. Azure, focuses more on enterprise, but I don't know. It's like do you want to eat the chicken rice from this store or that store? It's chicken rice. It's the same product at the end of the day. Yep.
After you have built like your platform, how much time do you guess that you have to spend on maintaining this platform, and which sort of tool would require the most maintenance, like you can scale it up or down?
Yeah, great question. So depends on the way you design the platform as well. If you're hosting infrastructure as code, you're doing everything by hand, like you're maintaining bare metal servers and you're putting code into those things. Then it's going to be very involved. If I were to give you an estimate, it would be like 10 or 20x the time spent actually setting it up initially would be the amount of time spent maintaining that. But if you use something like serverless or SaaS offerings, I don't know, that's maybe 2-3x effort-wise down the line to maintain that. Just make sure that the pipeline, if it fails, just quickly do some quick fixes, maybe source change or something like that. So yeah, it depends where you are, what kind of businesses you're working with. If your business is processing large volumes of data, then maybe human effort is cheaper than paying a machine to do all that work for you. And flip side is also true. If you're a small business, then you probably go serverless.
So for like platform project.
Yeah, we're really small, so serverless SaaS where possible. Yep.
I used to run DBT. Did you run it on Fivetran or?
Yeah, so DBT, we trigger that through Fivetran. That's correct. Yep. Any last questions? All good. All right, awesome. Thanks, everyone. That was the end of my talk. So that's the end of all the talks for tonight. We're going to be here for another, what time is it? Half hour or so. So feel free to hang out, grab some more slices of pizza, mingle, meet more people. But yeah, thanks for everyone for coming tonight, and we look forward to seeing you at the next one. And just before we go, if you're interested to speak as well, feel free to come and speak to me afterwards. We are always looking for speakers. Any topic under the sun, as long as data related, we welcome any topics. All right, awesome. Thanks, everyone. All good? Why Power BI? Because that's what I know.
Yeah.